So hey everyone, thank you very much for being here and attending the talk today. I plan to talk about building Angular libraries with the concept of monorepos, which is a lot very interesting when it comes to building multiple projects together and deciding about how to handle such projects, whether to keep them in one repository, whether to keep different repositories for each projects, and so on. So this is what we are going to be talking about. And I'll share a small motivation story before we get started so that you understand what monorepos are they even in the picture? Are people even talking about those? Are people even using those? So if we talk about the biggest giant IT company, right, Google, they use monorepos to handle all their projects, almost all their projects. So they have this one repository in which they will keep the code of all their projects and they handle all the code there. This is this one repository in which there'll be multiple projects which they're handling, which have the same versioning going on. And this is very important to ensure that if you're handling your projects inside a monorepo, you have to ensure that they all go through the same versioning process. And one test failure might break all of your other apps also. So yeah, let's dive right in and see what this is all about. Quick intro about myself. I work as an engineer at the company called TheDataworks, and I'm a Microsoft MVP, most valuable professional, and a Google developer expert in web technologies. And I love writing code labs and blog posts. So whatever I learn, I would put them inside that, and then for my reference later or for all of you. So yeah, when we talk about libraries, first of all, we know that this is definitely something to do with reusability, right? So we need to maybe reuse the project that we were building or some maybe component or maybe some particular feature that we are interested in and we might want to carry it to other projects of ours. I'll not say frameworks because if you're trying to, carry one particular functionality from one framework to the other framework, you would prefer web components, which is packaging your component that you build and then using it in, for example, an Angular built web component in a React project. That's where web components come into picture, and we're not talking about those. So about reusability, if you're trying to share your feature, not just one component, but a whole feature, a module or a service inside one project from this other project that you built in, that's where libraries come into picture. That's where this reusability concept comes into picture. So if you Google up the technical definition of what libraries are, it would say something like this. And it says that library is basically a collection of pre-compiled routines that a program can use. And let's try to comprehend it a bit with the words which are mentioned here. So it says it's a collection of pre-compiled routines, which means that there's some functionality which is working, and you can reuse it somewhere. It's a routine that you follow, right? And this is what you use in different projects of yours. A program can use it if it's made in a way which is already compiled, and then you can reuse it in a way. Now, there are a few features which a library should have, and specifically an Angular library should have, which are it should contain components, modules, or services, depending totally on the user's requirement. Then it should have shareable code, because that's the idea of creating libraries. That's the idea of reusability, right? Then we already talked about reusable functionality. And the best thing about libraries is that it has this dedicated code for a feature. I mean, you would know that, for example, I have a virtual scroll feature, right? And this is something that I want to carry to my all the other Angular projects also. And that's where I would think that why not create this one module which has just the purpose of this virtual scroll functionality and nothing else. This is that dedicated code. This is what I want to use in here and inside the other projects also. And I don't want to, mix and match with any other components or modules. And I want to keep it totally isolated and, dedicated for a feature. That's where, again, libraries really help to keep, separation of concerns. And then your one project can use that, but then the other projects can also use that. And moving on, this image is what I like a lot to describe what libraries are. And this was used in this talk by Yuri, which was about creating and publishing Angular libraries like a pro. And if you look at it closely, you would understand what it basically says. it would say that there's this Angular application which has multiple libraries, which are Angular libraries, connecting with it, or JavaScript libraries also. So it basically explains that how an Angular application comprises of the Angular code, first of all, comprises of the code from Angular libraries, comprises of the code from other JavaScript libraries that we use a lot on a daily basis, right? So yeah, this is kind of how the picture looks like when an application is using libraries and the code and the other libraries like JavaScript libraries. And this again is description for libraries in one of the it's a document called Angular package format, which is shared by the Angular team at Google. And that document basically tells you the whole format and the way you should build your libraries, the way you should build it in the sense that if you follow that particular document to build your libraries, you're ensuring that your library integrates seamlessly with your Angular code or any other Angular code. It follows exactly those guidelines. And if you notice, all the Angular libraries which we have already, right, they all follow that Angular package format document. And we'll talk more about that. And in short, we usually call that APF document, Angular package format. So yeah, that document says that a library is basically the smallest set of logically connected code. And we've kind of explained this already when we said that there's this library which should have a dedicated feature, dedicated code for a feature. And that's pretty much what it means here. It is the smallest set which has some logic or some feature that it does, and it's all bundled closely and connected well, so that this bundle you can share anywhere, give it to some project or the other project, and those projects can then share it and use it and use that same functionality. And now let's dive a bit deeper into what are the different features of a library in terms of how compatible it is with different kind of platforms. In this case, which is that a library should be platform independent, which means it should work with Angular Universal or web workers, right? And the next thing is that it should be bundled and distributed, which again we have talked already. It is very important for a library to be bundled and distributed, because the idea is reusability, right? And now this again was a feature for a library that and a library should be AOT compilation ready. Now we had to ensure it before, but then with the latest versions of Angular, we do ensure that because this is by default now. So we know that a library will always be AOT compilation ready. And we'll see more how tools help us to do this. And we don't really have to look at all these features specifically when we are creating the library. And all of this is handled well already for us. And yeah, that's where comes the document that I was talking about, the Angular package format document. And to describe it, it's usually called the recommended way to distribute your Angular packages so that you can integrate them with the other Angular applications, right? And what it ensures is that it talks about module definitions, how the module should be, how it should be AOT ready, AOT compilation ready, and what should be the entry point, what are the typing files. So that's about that. Then let's talk about steps to create a library, right? And this is very important because we talk about how inlining all the templates in a library helps us, right? This is when the bundled part of a library comes into picture, and it basically talks about how we should inline all the templates, all the styles of a component. There can be multiple components in a library, right? And we're not talking about one component because that it's not important for a library to just have one component. The next step that happens in the process of creating a library is compiling it with NGC, which is the Angular compiler. That's the next step that happens in the process. And again, as I said before, this all will be handled for us by itself, and we will not have to handle it each of these manually. The next thing that comes into picture is build formats. Now, when you're building your library, it is very important to, again, notice the different bundles that are generated when you're creating your library. So there are 3 bundles, basically. First is ES6 bundles that are generated. The next is ESM5, which is actually a combination of ES5 and the import and export from ES6. So it's basically all ES5 ES5, and then only one feature from ES6, which is the import and export feature. So it's kind of a combination of that. And then we have the UMD format, which also gets generated by our library. And we'll see when we build our library how these formats are generated. And you'll also see a caveat here that with the latest version of Angular, which is Angular 10, we do not have any more ESM5 bundles generating, and we'll see why. So that's going to be an interesting slide again. And now you notice that, all these slides that I was talking through, this seems to be like a lot of things you need to do before you actually plan on creating your library. And, you might lose the motivation already that, oh, okay, that's a lot. That's where a tool comes into picture and, allows us to do all of these very easily. And that's ng Packager. Now, this was a tool that was first done as an independent thing, and it would basically allow to build your libraries and package them using a single command. And what all it does is that it would create the library in the Angular package format. So it would ensure that whenever you create your library, it is in that format which is prescribed by the document in Angular package format. Then it creates all the bundles for you, ESM 2015, ESM 5, and UMD bundle. Then it would also create the type definitions for you. So that's the best thing, right? For example, I'll take my personal example. Whenever I'm creating libraries, I'm using libraries, and there are many libraries which do not have their type definitions. And for example, in a React application, it would always mess up if you're using TypeScript, because you need to have either a type definition or you need to specify it in the environment file, right? So that's where, when we are using it as a consumer, that's where we realize the importance of type definitions for a library. Then it would create AOT metadata file, which is again important. Then the best part, it also inlines all the styles and templates. So you don't have to manually go there, delete the files of the templates which are created separately. So it would do that for you. It will inline all the styles and the templates. So you basically have two things. Either you would, while creating your application, you would ensure that you're passing that inline template and style flag to ensure that the separate files are not generated for your template and styles. Or what you would do is that if you don't remember it while creating, what you would instead do is go manually delete those and then inline your templates and styles, which is not very friendly, right? And that's when ng Packager again helps you by doing that by itself. Now, also generates FESM and FESM 2015 bundles. Now, what is that? This is basically the flat bundles for ESM5 and ESM 2015. So it also produces the flat bundles for you, which ensures that you have the flat minified version of it also. And when we talk about ng Packager, you would be wondering that what's the configuration of ng Packager, what it really does, and how does it ensure that so many things would be done for a library. Now, this is basically what it looks like. You specify an entry file inside your ng package configuration, and that's where it picks the component or service files from. So you can always give it a different name, but by default, it's called public API.ts. And then you specify the destination, which is the dist folder. And again, you can change the name and you can go ahead with a different name, but that's by default where your destination, which means the built library, will be produced. And now if you look at the entry file, which is public API.ts, this is something that it will look like. It basically, the idea is to export all the things that are in my library, which are going to be used by the consuming application. In this case, I just want the component and the module. I want my library should be exporting these two so that whoever is consuming my module or the component should be able to use these. And that's why we actually call the public API TS or any entry file with any name as the face of your library, right? It's kind of interacting with the outside world. Nobody knows what's inside unless you have good type definitions. So basically, public API TS is the face of your library. And what you then do is in the consuming application, you would import the module, you would import the component, or just module if you have components specified inside the module from your library. Then a quick graphical representation, because we'll go through the code also for this. So I'll quickly explain what it does. You have these library files. You have the public API DS file, you have the packet.json, and you have all the TypeScript files for your component and module. It goes through ng packager. What ng packager does is that it would create all these files inside your, and as per your Angular package format. First, it will create the type definitions, d.ts files. Then it will have a package.json, which will specify your library related information. Then it will also create all the bundles, the bundles that we talked about, ESM5, 2015, and UMD bundles. Then this is where we start the process of actually creating a library. And I'll quickly go over these slides and then actually do this, while demonstrating it to you. So we were talking about ng packager until now, and I was saying that this is a tool that helps us a lot. But is it an external tool that we use? Now, since ng packager is really helpful, right? Angular CLI has ng packager under the hood working. So now we don't need to even go for a different tool, and we just need to use Angular CLI to create our library, which again, under the hood uses ng packager. And what it basically does, you would simply use the commands just like all the other schematics that you have, ng generate app, ng generate module, similarly, ng generate library, and then the name of your library. So this is what will run ng packager under the hood, and it will create all the different type definition files for you. It will create the bundles for you after you build your library. So this is what creates your library with the help of CLI. Now, let's, these are all these steps I kept here to, use if my internet doesn't work or, something glitches. So let's not go through these, and let's go straight into the code now, which is here. So this is where I would like to, let's just keep it here. Right, this is where I would like to create my workspace, first of all. Now, since we're talking about, let me just minimize this. Yeah. Now, since we are talking about monorepos, right, that's where this part is very important. So now you would see that whenever anybody creates a new Angular application, they would just do ng new and then the name of the application, right? Now, I don't want to create an Angular application, right? That's not the thing that we're trying to do. I'm just trying to create an Angular workspace inside which I have a library which I'll be building, and then I'll give it to any app that wants to use it. So I'll just do ng new. I'll give it the name of the workspace that where my library or the app exists, and then let's call it, for example, TechWebinar, right? Nepal. Let's give it this big name, or let's just call it Tech Nepal, right? Yeah, ng new Tech Nepal. This will create the application for me, and I don't want to create the application. That's where we use the flag create application equals to false. So we'll just pass it as false to ensure that the application is not created, but I have the Angular workspace. ng new Tech Nepal -- create application equals false. And now let's see what happens. So you see it's creating the important files, which are the Angular configurations like angular.json. Then you always need package.json and tslint, tsconfig, TypeScript configurations, and then it starts installing the packages right away. So yeah, we are installing the packages here, and you would notice that the workspace will look like an Angular workspace, but it will not have that app folder which has the task of which has all your components, modules, and services. But instead, you would have this workspace, which let's wait for, and in the meantime, let's go to the slides, which is here. Right. So yeah, this is what your workspace will look like, right? And the idea is that first of all, you have this projects folder, and outside that you just have angular.json, package.json. That's the workspace. You don't have any app there that you see, right? You don't have any Angular related components or services or something like that. So let's go back and see if our app is compiled. Yeah, so it says that packages are installed successfully. Let's go into the app the workspace that we have created and open it here. Right. So you see that we have nothing but only these important files here, which are package.json, angular.json, node modules, which are the dependencies which are installed, if there are any, And now if we look at the angular.json, right, this is the part where we have to focus. You see that there are new projects in this workspace. And this basically means that we might be able to have many projects, which means inside one code, you have many different projects going on. You might have multiple applications, you might have libraries, and so on. So if we want to add or any application or a library, we would go back to the command line. And now let's create a library inside this workspace. As you see, currently we don't have any source folder, any application, any components or modules. So let's go here inside this workspace, ng generate. I want to generate a library, and let's call the library as techlib, tech-lib, right? That's the name of our library. So let's generate this library, and let's do the necessary things here. Yeah, so you can see that inside projects folder. So you have this projects folder inside which you'll be creating all your applications or libraries. You have the angular.json, which is updated, not created, and package.json updated. All the other files which were already created, they are updated. And let's see what the update is, right? You see the angular.json is changed here. And if I minimize it for a minute, and let's bring it here. Yeah, you will see that now your project folder has actually one project, which is techlib, which is our library. And if I open it here, you will see that it gives you all the necessary configuration, like the project type, which is not an application but a library. Then it will give you all the paths, and then prefix if you want to specify any, and yeah, all these necessary information about your library, the test related information, linting, and etc. Now let me go back because they have not made any changes here. And it's still installing packages for my library. So in the meantime, let's go back again to the slides and see what's happening here. Yeah, so you see that what are the different files in here? You have a lot of files actually, and I think we have this in the code as well. So if I go to projects, you see inside projects I have techlib. Let me close this file. Now, you see that we have two package.json files already in the whole application. Now, not to get confused, this is very important. The first package.json is the global for the whole workspace, right, which contains all the dependencies the whole workspace will be using and all the scripts that you would be running for your to run from your command line. Then you see this other package.json, which is your library-specific package.json. And this is very important because this is what contains the information related to your library. It gives you the name of your library, the version, the peer dependencies. Now, peer dependencies are, you can just understand it as the dependencies which ensure that, if whatever is defined under peer dependencies, if these things are available for your library, it will run smoothly with your Angular application. So in this case, Angular Common and Angular Core, which are the two main packages, are required as peer dependency for your library. If these two are there, then it ensures that your library will be running smoothly. And yeah, that's about package.json. ng package.json again is what we talked about already. If I increase the font a bit, it might help you. Let's give this. Yeah. So this is the ng package configuration that we saw in the slides before, and it was given something like this, right? ng package, and then inside this we had something specified like this, right? And if I enclose it in the, yeah, something like this, right? So this is what we saw in the slides wherein this was basically the ng package configuration when you were doing an ng package tool itself. But now since CLI is doing that for you, it ensures that you have this file called ng package.json, which is actually the configuration for ng package. So you don't need it as an object here. So let's go back. And it basically means the same thing. You have the schema wherever ng package is coming from. So you see it's coming from ng packager dependency, the destination file, the library entry file, which is by default, like I told, is public API.ts. Let's close this. Let's go here. Then you would see all the linting related files, psconfig, and if now let's go to src, right? Inside src folder, you would see that you have the public API.ts, which, like I said, is the space of your library. It's exporting three main things from your library, and you can choose to ignore the service. You can choose to comment this here if you don't want to export this. If you have nothing related to dependency injection going on in your Angular application, then you have your component which is exported and the module. You have this test file. If you're into test, then you can look into this. Then you have this lib folder, which is the main target for us today. So, right, you can see that you have this component.ts and the test related file for that, the spec.ts. Same for your module, same for your service, right? And that's all. You don't have the HTML file, you don't have the styling related files because it's all inline. Who did that for you? Angular CLI. How did it do that for you? ng packager. How did ng packager do it for you? Because it follows the Angular package format, which says that you should inline all the styles in your templates. And now if let's go to the component and look at it, you see that inline template is here, the styles, and it basically does nothing but says that techlib works. And let's just change the, whatever text it gives here, and let's say welcome to techWebinarNepal, right? Yeah. So this is what we have changed in our library. And for now, because this is a demo, right? Let's assume that, okay, this is our library. It's a very important functionality library that we're doing. And we need to give it to the whole world because such a good feature we have implemented here, right? In our library. So yeah, you can see now if you go to the module, it includes and exports the component, techlib component. So if we just export the techlib module from, our public API.ts file, not the component, not the service, it should be fine because our module contains the component, right? But you have to ensure that you also export the component to ensure that it also is presentable to the consuming application. So let's just undo this, undo this, undo this, undo this. Yeah. Let's go back. Then you see your service file, which will come into picture only if you're doing something related to dependency injection. For example, you have any other service inside any other component here, you can just inject that the way you inject in a regular Angular application. My service, and let's assume that you have a service called my service in here. Then just like that, you would be able to use this something like whatever method inside your service is. Since we do not have any library, so this was, we can get rid of this. Right, so that's about the service. Now we see that we have almost all the things done in our library. We have the component which is giving out the message as welcome to techWebinarNepal. We have the module which includes the component. We have the public API.ts file which is giving all the required information to the consuming application. We have specified the versioning and that was done through CLI. So let's go back here. In here, you see that our packages are installed, all the required things are updated, the files meaning angular.json, package.json. Now the next thing, since our library is ready, we would want to build our library. So now let's go to package.json, which means the base package.json, the application, the whole workspace package.json. And let me close this to avoid confusion. But you can see in the path it mentions that package.json of techlib, which is the library, and this is for the root. Let's get rid of this, open this, and inside scripts, let's give a build script so that you don't have to write it every time. Build lib, that's what let's call it. And in here, we would just say ng build and the name of my library, which in this case is tech-lib, right? So yeah, let's use this command, this script, to run from the command line, and I would just say npm run and the build lib. That's the script. Yeah, so that's the idea. I had saved it here. Let's go back. npm run build lib, and you can see that it has started to, build your library. And we should notice each and everything that's happening while building this library. And let me see if I can, increase the font. I hope this is better now. Yeah, so the first thing it says that it is building the Angular package. Now, there's this very important thing that it mentions here. It says that it's not recommended to publish IV libraries as of now to NPM repositories. So since I'm using the latest version of Angular, which is Angular 10, it tells me that, you cannot publish IV libraries for now to NPM repository. You can't publish it as a library package to NPM. But As per the latest Angular roadmap, we hope that in the next release of Angular, we will be able to publish IV libraries also to NPM. So that's very much in the roadmap, and we can expect it as the next thing. Then the next thing that we see here is that it's building the entry point, which is obviously the most important thing of our library. And the steps that it does is that it compiles through NGC, the step that we talked about in the slides before. So it has to ensure that it compiles it through the NGC compiler. Then all the bundles that it needs to create, bundling to FES in 2015, UMD, minifying, and to create the flat bundles also. Then it gives you the destination file, which is dist/the name of your library. So it seems that our library is built. Let's go here. We can see the dist folder. It's just like how it is for the app, but then inside this you would have the library name, right, to ensure which dist folder, which build package it is. And again, this is very important to notice each of these things here. Let's close this package.json. Let's first of all go to the d.ts file, the typing file which we have. We are grateful for that. Then public API.ts file, which is again, acting as the important things for our module, component, and service. Now there's one more package.json, so 3 package.json files. And this is what basically tells the consuming application, because the dist package is what we transform and give to the other users, right? So it tells that what are libraries it is using, what are the different bundles this library has. So all the information that the consuming application needs to know is there in the package.json. Then if you go inside the lib folder, these are the 3 d.ts typing definition files generated for your component and module and services. If you close this and go to the bundles, you see you have the UMD bundle generated, all minified here. Then you see all these files. Close this. You see that ESM 2015 and the flat bundle for that is generated. We already saw the UMD bundles, but there is one missing. And what is that? The ESM 5 bundles, right? And that again comes back to the point that with Angular 10, we do not have the ESM 5 bundles generating anymore, because the down leveling to ES5 happens only after the build time. So this is one caveat when we are building libraries with Angular 10, that we do not have any more ESM 5 bundles, but we can manually down level also and then generate these. If you look at the ESM 2015 bundle now, you would see that it has, it has techlib.js, which is just exporting whatever is there in the public API file. Then again, all these files which are important for us, and inside the lib, again, it has the type definitions for as per this bundle, ESM 2015. The same for the flat bundle. You can see here. Right, so we have seen all the bundles also now. And the next thing, after we have built our library, is to tag. Now again, there are different ways to be using this library. You see that you've already built your library and you should be able to give it to anyone else without having to publish it to NPM, because maybe it's just for your internal work, right? And you don't want to publish it to NPM and just want to publish it to maybe internal repository, or just don't want to publish it anywhere because you want to just use it for your own purpose, right? For your own project. And that's where you can decide which method to go for when you are using your library. That makes me go back to the slides again here. So we have seen the steps. Let's go ahead. This is where the usage of a library in a separate application comes into picture. You have the first option, which is npm install if your library is there on npm. The other option is to npm link, in which case you don't want to really install it inside your application, but you just want to link it on npm if it exists there and just use it from there. And then you can use the npm stack to finally pack your library, and then just get the packed file, and then give it to whoever whoever is needing your library. So for example, I would pack my library, but I don't want to publish it to npm, and then I would give that packed file to my friends, colleagues, anyone who wants to use it, but not let anyone know about it through npm or anywhere else, like not make it public basically. So the next step for us is to actually go ahead and pack the library. So there's the code in here. Let's go to the global package.json, the root one. Let's copy this here, or let's not. Yeah, the other script that we are writing is for packing our library. So again, pack lib in here, and the idea is to what? The idea is to pack my library, right? So first of all, we need to go inside this dist folder that you see. So let's cd dist slash tech-lib. Yeah, and what do you want to do? You finally want to pack your library. So you would use npm pack. That's it. So you would go inside this to ensure that npm pack understands what exactly to pack. Otherwise, it would pack the whole application or whole workspace, which is not what we want. So we would go inside only the built library content and then pack that. So let's save this, pick it up from here, ensure that we're doing everything right. We're going into the dist folder inside the library and then packing it, right? So yeah, let's go to the command line, which is here, npm run, and then the command which is pack lib. So now I'm going to pack my library. Let's see what happens. Right, so this is very interesting. You see that a lot of files are actually tagged inside this package that we have created. And you would see all the bundles here which we created and are tagged inside that. So basically all the contents of your dist folder inside the library are packaged. And these are the details which are again very important, which gives the name of the library, the version, the file name, which is just generated, the package name, then the package size, which is just 6 KB, obviously because we have nothing more than a title in there. And then the other information like, the file information and the total files inside that is also mentioned here. So yeah, this is the package. Now, if you don't want to do anything after this, you don't want to publish it to npm or any other step, just pick it up, give it to anybody who wants to use the library, and that's it. Your local distribution of library is done. Your library is ready. If anyone wants to use it, they can use it. Go ahead and use it. And I'll show you how you can do that as well. The other way is to use this package, publish it to npm, and then use it from npm, right? Now, for doing any of these, we need to create an application. We need a consuming place, a consuming application where you would actually need to use the library. So let's do one thing now. Let's go to the project here. We have everything mentioned in here. I have projects in which I have the library, but I want this application now. Now you have two options. Either you can create a different application in which you would have all your consuming application related code. But since we are talking about monorepos, why not have it inside the same code base? You can have multiple projects inside the same code base, right? That's what monorepos are about. So let's go here. Inside the project, I would want to create another application. So I would just say ng generate. You can use G as an alias, and you want to create an application now. So ng generate app, and the app name, let's just call it consume. So it will create the application for me. It says, do you want to add Angular routing? I would just say yes. Any styles? Let's go with CSS, and it's creating my application. Again, you see the app folder is not generated in the root, but inside the project folder, because now it has to ensure that all your projects, whether the project type is the library or the application, are inside the project folder. Let's go to the application now. Yeah, so you see here how you have this techlib, which is a library, consume, which is application. And now if I go back to the angular.json, you would see the change in the project object where first is your library and second is your application. And you can, if I close both of these, you saw here that the project type was library in the case of techlib, which is a library, but in the case of consume, it will be application, right? The project type is application. All right, so let's go ahead. And we have the consuming application also. Now the idea is that I want to consume this library inside this application. So I would like to install it using the whatever package is there, right? So I can just go ahead and do, let's go here, npm install, and then give the path to my whatever library I used, right? Since we use npm pack to pack our library, npm has the information of our package. And I can simply do npm install, even if it's locally, npm install. So the path is this slash, what is it? techlib, right? And then the package name. What is the package name? This is, right? Let's copy it from here, npm install this slash the name of the library slash the name of the package and enter. Right. So you see that we have added the techlib library inside the application. And if I now go to the project here, the workspace, I should say now, because we're dealing with multiple projects. Let's go to package.json. And in here, now this is the most important part. Now, since you're doing this locally, you would see that your library is added as a dependency, but since it is just a file that you're using, it's not a package, right? It's a file that you're using locally. The path will be prepended by this file colon keyword there. This basically means that you're using the dependency locally. So this is a great thing to notice here. And then, you would use the same thing. You would be able to use the selector of this library inside your application. And I would also show you the other way of installing your library after packaging it. So let's go to that, and let's just leave it here for now. We have packed it. We have the package. We've talked about this. We have it here, right? So actually, let's go ahead and use it right away. Let's keep it to this size at least. Yeah. Now, the important part is to be able to use this library inside my consuming application. So let's go to src app. Then let's go to the app.component, app.module.ts actually, because that's where we start the whole importing of a library from, right? Now, let's see if it suggests something to us because we have it imported. We have it installed as a dependency. Now, I want to import something from this library called, what is the library called? Techlib, right? So it shows as a suggestion, right? So I want to get something from here. What do I want to get from here? Anything that the public API TS file gave us. What did it give us? The module, the component, and the service. I basically want to get the module from it, and it would be called techlib component module or service. You see, we have all the three suggestions from this library. I would want to get the module from here. And if we're using importing, we would just add it to the imports array. Right. So let's just save this. Now, since I have the techlib module, I should have everything which is available inside. So let's go to the app.component.html now. And let's just get rid of all of this code here, which is the default HTML, which we don't need. Now, first, let's give it, a simple div tag, which says that I'm the consuming application, or hello from the consuming, consuming application, right? And then you have this other part of your HTML, the view, that gives you the other information that's coming from your library. Now we need to ensure what is the selector that we were using in the component. So maybe I don't remember it now, right? So we can go back to the library. We would go back to the src folder, or since you would not have this available, right? But you have the this folder. In that case, what you would do is that you would go to the lib, then you would go to the tech component.ts, and in here you see that what is the selector? Lib techlib. This is the selector component. So I'm picking it up from here. Let's close this. I want to basically use this selector, which is it's not suggesting, but that's fine. Right. Let's save this now. And if we go back here and try to run our application, you see there are basically three steps that we have done. First, we went to let me close the library. First, we went to the application folder inside the src, inside app, we went to app.module.ts, and we imported the module, which is techlib module as per our library, and we have added it to the imports array. The next step is that since our module exports the component, we should have it, and so we will go to the app.component.html, get rid of the code that is already existing there by default. And then you would want to give us two messages. One from the app that you're using, even if it's an app in a separate workspace, and then the other message should be coming, or any other information that our library has should be coming from that. Once that is done, your application is basically using the information from the library. So let's compile it, and it is still compiling. So let's wait for that. And yeah, in the meantime, let's go back to the slides, see if we have done all these steps. So yeah, we installed it. We have it here. You can see that it has the file pre-pended in the name. The next step is importing it as a module. We have done that. Then using it as a selector, we have done that. Also, if you notice here, also it's in like, for example, it's from a different application, right? This is also prefixed with lib hyphen and then the name of your library. If you want to avoid that, you can just add a prefix by yourself so that you have the exact name that you need for a component. For example, libtechlib doesn't make very much sense, right? And you would want to give it some meaningful name. That's when you can use prefixes and aliases and so on for that. So yeah, once you add that, you see the name coming from the library. And we'll go to publishing after this. Let's go back. Our application is compiled and it's running here. So let's go to the, open another window here. Right. Right. So this is very interesting that you see here. First is the message from your consuming application. The second is the message from your library. That means you're able to use it locally now. So yeah, that's about your, consuming your library inside the application locally, first of all. Then comes the publishing part. So let's get rid of that. And finally, you would want to publish your library to NPM if everything works well, right? So let's close this for the moment. You have everything working here. And now you want to ensure, let's just get rid of all these steps, right? Let me get rid of this. Yeah, let me get rid of this as well. I'll tell you why I'm doing this. And let's get rid of the local dependency from our packet.json, right? So we are back to the regular application, Angular application that we would have. And now what I want to do is that I want to publish my library to NPM. Now, since I have the package ready, I should be able to do that, right? But there's a problem. The problem is that NPM is a mass repository, and there might be many libraries already which are with this name, techNepal, for example. Not techNepal, let's see what's the name of the library, tech-lib, right? There might be many libraries there already with this name. And that's where you would need to go to the library, which is techlib. You would want to go to the packet.json file, which has the name of your library and the version. And this is where you would want to keep it specific to your account. For example, if you've seen the Angular library, right, Angular framework package, it is something like this. Why? Because it is inside this workspace, and this is the package name, right? So you have to ensure that it comes under your name so that you have infinite names available for your libraries and you don't get stuck. And if you don't want to do that, ensure that you have a unique name, right? So in this case, I can just do, for example, this is my NPM account name. So @Nishu Goel / then the name of my library, right? So if I go back, once you do that thing, you would have to build it again and pack it again. So all those steps will repeat. And once that is done, let's close this for the moment. And now the next step is to finally publish it to NPM. Now, if you're not logged into NPM already, you would want to do NPM login, then enter your name, email, and password. And I want to check if I'm logged in or not. So I'll just say NPM, who am I? Yeah, so it says that I'm logged in already, and I should be able to publish my library to NPM, right? So, yeah, let's go here first of all. Right, so the first step in the publishing process is logging in, which you've done, giving it a version and a name. Now, version depends on semantic versioning, so you might want to read up more about that. It includes the patch version, major version, minor version. So that's very important. With every release in your library, you would have to follow and specify it in your package.json. Then finally, you can publish it with the access flag as public to ensure that it's it is published publicly. If you want to do it private, you can do that as well. Yeah, so you see that I changed the name here from techniquelib to the workspace name, the account name. And then the simple part, the simple step is to finally do npm publish and the hyphen access as public. That's the flag that you pass to ensure that it's publicly published. That's about publishing your library. And if I go to my npm now, let's open a new window again in npm. Let's see if this is logged in. Okay, it's not, that doesn't matter. So let's go to my account if I can go from here. Right, so you see that I have all these, for example, the technique library that I was showing you, or the demo library that I've created here. All these libraries are inside my name. And even if I'm giving such random names like demolib or mylib, right? Imagine how many people would have libraries within mylib. But since it's under my name, it doesn't matter because it's my own unique workspace and I can have any name, even a single word name if NPM allows that convention. I can have that name as well. So yeah, klib, for example, see such a casual and a random and a small name my library has. nglib, how many people would have that? So yeah, keeping an account name before the name of your library really does the trick. Okay. Now comes the main part about monorepos. Let's first have a look at this. Right, you can see we have libraries uploaded there. Then this one just says that, oh, we were able to create the library and publish it to NPM, right? Now, there's this other way to do it when you're talking about monorepos. So this is the last bit which I quickly share and tell you that there's one more way to do it. Now, when you're talking about monorepos and you want to ensure that your whole setup is actually done in a way that it really pays the focus on monorepo architecture for your Angular application, it ensures that every versioning is done properly for your different applications or libraries inside your workspace. NX is a great go about it, and it basically ensures that your Angular, the workspace, which contains libraries and applications, is following the NX toolchain, and then is creating every semantic versioning as per all the different applications. For example, a very good example of this is if anybody of you have wondered it before that why after Angular 2 we had Angular 4 directly. Why did we not have Angular 3? Did anyone notice that before? We don't have Angular 3. Why is that? Now this is very interesting because we don't have Angular 3 because of monorepo, because the code base is contained in a monorepo and we have different packages, Angular router or Angular material or Angular, maybe any other packages of Angular inside one repository. And when we were on Angular, there was a lot of changes that were happening on the router, which made the router release go to version 3 already. And now, since the Angular router was like Angular router 0.3, 0.0, point something, right? This version. And when we would have introduced, don't tell me if you get confused, but when when the Angular team was actually releasing Angular 3, was going to release Angular 3, the router had so many changes that with the latest release, the Angular router package will go to Angular 4, which would be a mismatch in the versioning. So you understand that the router has so many changes that it was going through 3.1, 0, 3.2, and so on. Then it was able to reach to Angular router version 4. And if they had released Angular version 3, the router would have gone to 4, which was a mismatch. So what they did was that they directly jumped to Angular 4, ensuring that now the router also is at 4 and the Angular whole repository is also at version 4. So this was why Angular 3 was never released. And these are some of the things that you need to take care of when you are, strictly following the versioning inside a monorepo, when you have to strictly follow the versioning. So yeah, that was an interesting thing that I got to know about, monorepos, and as a good example of that. So let's quickly see what all are the, ways you can do this. So yeah, whenever you're using NX, now let's say your organization is, using Angular for a long time, and they would not be really comfortable with, switching the whole tool chain, the NX CLI and so on. And they would maybe, many developers may be just comfortable with Angular CLI and they would not want to go to NX CLI. So that's when NX CLI to follow the whole tool chain and, do your monorepo workspace using NX falls a bit, because not everyone, especially in large, organizations, is comfortable with just switching the whole tool chain. So the other way around this is that actually use Angular CLI, but with the NX style workspace. Now you will see what that means. This is basically that you would use the Angular CLI, but then different dependencies will do the work of NX toolchain for you. Let's see what happens there. Right, so this is what we do in that case. So inside your Angular application, you would use Angular CLI to install these two dependencies. First is Narwhal schematics, which is helping you with all the schematics that NX would have. It is like we have ng-generate or ng-add inside Angular. Then you have this other package, Narwhal NX, which is doing the role of, which is giving you all the features and properties of NX as a project. When you have those two done, the next step is to create a workspace. Now, I hope that you'll be able to relate it a lot to what we have done in the Angular CLI project. First, we created the workspace, right? After we had the dependencies necessary. So create NX workspace. You're specifying that this would be NX workspace. Then you give the workspace name. And you can also give a scope for your NPM so that every repository or maybe every project in the repository remains inside this scope. You ensure that, okay, these projects are of this scope and they should remain inside this. Once you create the workspace, the next step is to generate the app if you want the app, or the library if you want the library. So basically 3 things: create the workspace, have it done as per the NPM scope, right? And then all the libraries and apps that you build with that scope name will be inside that. It's just like using a tag in Swagger, for example, when you build your APIs. Yeah. So you generated your app, you will generate your library, and you would see again something like this. Inside the projects folder, you would have the library and the app, application, whichever project, multiple projects you have, it will be specified there. And when you have that, then comes the packaging part and the publishing part. Now, this is again a caveat with NX when you're using it. So while packaging, you would not be able to package it just like you did in the case of Angular CLI by just packaging it using ng packager or npm pack and then publishing it to npm. It's not so easy. That's when NX falls off. And what you do in that case is that you can create a separate configuration file which does the whole role of ng packager, like be able to pack it as a package, then publish it to npm. So that's where some extra work is involved around creating this npm ng packager config file and then allowing your NX library or NX workspace to be published. Basically, NX library to be published to npm. So yeah, that's about packaging with NX. And if you're interested in NX more, you can go to the official documentation and read more about that. So yeah, that's about NX. I come to the end with this, and these are two, the GitHub repositories that I'm sharing here. And these are two because one is totally about creating, and it's not a monorepo. So the one repository is about creating a library, and the second one is about consuming it. So you get the code for both. And these are some great resources that you can follow with our, which have interesting stuff around monorepos and libraries and Angular libraries and NX and so on. So first of all, the official documentation, then there's this library series on Angular in depth. There's this great course, which is, very deep dive into libraries by Fabian Gosling. So you can go for that as well. And there's this talk, which I already shared with you, which is create and publish Angular libraries like a pro, which is great. And then there's this step-by-step guide that I have written to be creating your first library and publishing it to npm. So you can read that as well. So yeah, that's pretty much it. And in the end, I would just like to thank you all for coming here and listening to me for so long. You can connect with me on Twitter or GitHub. So yeah, thank you very much.
Thank you, Nishu, for a wonderful presentation. So we have one question. So can we view the templates for library from browser during the development stage?
Can you repeat the question, please?
So can we view the templates for library from the browser during the development stage? So the question is about the library template.
Oh, okay. Yeah, so you have many extensions doing that. Just like for React, you would have the React Developer Toolkit, right? Which allows you to view the different components. And I can append the the links to those extensions in my slides that I'll share later with you. So that's one way. Also, for normal debugging while development process, you'll have all those available when you attach the the selector in the application. Only then would you be able to expand it like an iframe or so, and then see the selector inside that. Uh, like apart from that, you won't be able to just view your library in the browser when you're developing it and be able to view it in the browser DOM or something. You won't be able to do that because it needs to have a selector, because the concept of browser says that there is this selector that's attached to the DOM, which the browser understands, and then it takes you further down that, which in the library development process is something we are not doing, right? We are doing it only when we attach it to the application, which is viewing in the which we are able to view in the browser. So yeah, I hope I answered your question.
Yeah, thank you. Thank you. So as you told about the thing about Angular, after Angular 2, Angular 4 has came, not Angular 3. So just like that, I want to reference with the .NET. So in the .NET also .NET Core, so there is a .NET 3. So there is no .NET Core 4. Still, it is having .NET 5. So it is still releasing. So the Angular had some strategy with the .NET Core. So like that, because in .NET Core also there is no version of .NET Core 4. There is only .NET 3 and .NET 5, which is coming.
Okay. So I have no idea about why .NET 3 was not released, if that's what you're saying. And the idea for this one was basically about monorepos and maintaining the consistent versioning. And it's very much possible for .NET also, but I'm not sure if they're doing monorepos in that case. So depends.
Okay, okay. And can you say something about the web assembly? So now the future will be the web assembly only. And so what's the the future of the Angular of the SPA framework? So something like on this talk, short description.
Um, this is kind of controversial, right? Because everybody's saying that WebAssembly will replace JavaScript and all, but that's not really the case, because Rust itself or WebAssembly itself, they say that this is not a replacement, but it will be like hand in hand, because the idea is that JavaScript will still compile to the assembly level code, right? And yeah, so JavaScript code that you're writing again comes down to the same thing, which means that you're not replacing that. There might be many web applications that you would be doing with WebAssembly, but that doesn't bring down the amount of work that's happening on the JavaScript end, because these are two different things that will still go hand in hand. But yeah, it has a bright future, as you said, and Rust is something that's like picked up crazily, and the way it's memory safe, just like we have TypeScript as type safe, we have Rust as memory safe, right? It ensures that the memory doesn't leak, and the compiler wouldn't even compile your code if there's some memory leak, which is not there in other languages. So that's the most positive part I feel with the Rust is, and WebAssembly also.
Okay, thank you. So thank you, Nisha, for a wonderful presentation.